Hello. Not looking at you, I'm looking at the camera. How's everybody today? We're missing a bunch, but I'm glad you guys are here. Let's see. Last time we had a lot of people come in after time. I guess 12:30 is too early. Definitely too early for the 8 a.m. people at 8 a.m. So Snake Eyes here. Great. We're going to look at file handling today. First, though, I was wondering if anybody would show us their survey app that they did. Do we have any volunteers? I'd like to see it. I'm going to turn this video off so someone can take over. Show us. Does anybody have it done? I know you do. Lots turned in. I don't want to pick on anybody remotely. Nobody's got it? Oh, you guys. Oh, shoot. Let's do it. Save the day. Oh, and it's awesome. But we can't hear you. Do you have sound? He's doing the... Oh, no. This is probably better than some of the apps they're using. Shh. Oh, no. It's awesome. Okay, that's too good. Can you show us your code? Cracking me up. That looks so good. That's super professional. Oh, very nice. Don't need. Very nice. And in the form, uses the survey class, sets up this super helpful message. And then in the submit button, oh man, I was already feeling old today. Resets. Oh, very nice. Got clear. That's how you find out those things, huh? Oh, that looks awesome. Let's give him a hand. Find your participants screen so you can clap for him. Yay. I'd like to clap more, but it just turns it off. Duh. Okay, now we have some clapping going on. That's what we want. All right, anybody else? I know that's a hard thing to follow there. Anybody? Nobody? Oh, I was gonna take it. Oh my goodness. This is pretty. Nice. Oh, look at that clear button working. That's really nice. Did you get the calendar control to work? I know it can be kind of a bear. Ooh, nice. Yeah, the color is really cool, the background color. Oh, got properties. Very nice. Beautiful. So, oh, that looks really good. Super effective code. Everything looks awesome. Yay. Logan says he's not at home, so he can't show off his. So, too bad. Those looked great. Okay, I'm going to jump in. You ready? Let's see what we can do here. Get this out of the way. Hope everybody had a good weekend. It was a fun one, right? Let's see. Yay. Hope you guys got to relax some. This thing's not wanting to, there it goes. Just didn't want to click for me. Too much going on in my poor computer. You know how that is. I want, you guys have done the best job out of all the classes with Zoom. And so I was just going to kind of remind everybody about it, because that was one thing that I did conversate or complain about, whine about to people this weekend, that my whole life consists of talking to black boxes. I don't get to see anybody's face anymore. And that's okay, because we don't need our video on. I don't mind that. But it's nice to have feedback. So in the participant screen, you've got the option to clap and, say nice things, ignore those not nice things, but, say yes or no. I've got to turn my clap back off. That's one that I always forget, because it's like I want it to stay clapping for a while. So, say yes or no when there's questions if you can. I know you have a lot of things going on your computers also. And then the one that I'd really beg of you to use is the away icon. So if you have to step away, go ahead and set that little clock icon so that we know you're gone, so that we're not all trying to get a hold of you, so that we can see some brilliant thing that you've done or something great that you've said. So just so that we're not waiting for you, that would be awesome. We'll figure out all these great Zoom things. But first, sequential data files. This is a great important topic, because computers are built for files, right? That's why they made them. We needed to be able to store and manage data, and most of that data had to do with calculations, right? We don't like doing the math, and we don't like keeping all that information. So that's what computers are for, and so we keep all of our data in files. You've known that for a long time, that we always save data in our files. And when we create a file, that gives us the ability to make our data persist. So persistent data is data that is available over a shutdown. So whenever I shut a machine down, I lose all the contents of memory, all that kind of data. I want to keep my data, make it persistent, so that it stays around. And then I'm about to keep re-entering it every time. Okay, so some really important file differentiations. We have program files. We know we've been working on source code files. We've been compiling them to object code files and executables. And we also know that data files are important. So they kind of cross over a little bit, but the main difference is, if we're looking at a data file, we've probably got some sort of formatted data content. So here's a data file. It comes from the 120 textbook, so you might have seen it before. But a data file, like this is a text file, is comprised of many rows. So in this particular data file, we have a row for each different student. Now, each of these rows is called a record. So a data record or data row. And within the record, we're going to have individual columns of information. So we have the name, and we have like 4 test scores. So maybe name, test score 1, test score 2, 3, and 4. And all of that information, those test scores, relate to our Abrams. So a given row of data is related. And whenever we're looking at each of those columns, we refer to each of the columns as a field. So a data file is comprised of records, and a record is comprised of fields. So we look at this data file, we might want to process this data file, and maybe we want to print out the name of each student and their average test score or something like that. But we're gonna need to process this file somehow. Now, an important concept that you can remember really easy if you think about entertainment in the days gone by. If when you were young, you maybe had a VHS or a VCR, and whenever we worked with VCR tapes, if we wanted to find a specific spot in the tape, you have to use the fast forward and the rewind, no matter what, to get to a certain spot. That's because a tape, like this tape access, is sequential. I can move forward and backwards, but I can't jump from position to position. That's different than a DVD or hard drive, any sort of digital storage, because with digital storage, I have random access. So I can jump around, I can go from one point to another specific point. And that's important to us as we're processing data. In the olden days, back before direct access disk, everything was on tape. So there could actually be some old and goldie applications that process everything in a sequential manner. And that's what text files are based on. So whenever I'm working with a sequential file, or even a binary file in a case, I have to follow a specific pattern. So when my program starts, I have to open the file. When I open the file, I'm going to be looking at the file's name, right? Where do we find this file, or .txt file, or .ini, or whatever it is. And if I can find the file, it's going to be open by my program. I'm going to read the first row, or the first however many bytes basically. And then I'm going to check to see if I got data. Did I hit the end of the file? If I did not hit the end of the file, I can process the data that I received. So I could process that student's name, calculate the average of all of their test scores, and then I'd be ready to return back to the file to read the next row. Now, if that row were available, I did not hit the end of the file, I'm going to process that row, that student's average, and then I'm going to read again. And I'm going to keep reading each of those rows or records in that file until I reach the end of the file. When I reach the end of the file, I'm going to close it and then be done with my program. But I have to specifically close that file to let the operating system know that I'm through with that file. It's now available to other applications. So when I'm working with a file, some of the classes in C# refer to it as a data stream or a bit stream. And I want you to think a little bit about streams. Streams themselves are kind of flowing. I guess I want to go outside some too, right? I'm ready to get out. Streams are flowing and they're nice and continuous. You can imagine you can have a kayak and just flow right through that stream, right? They can contain a small amount of water or a large amount, and they can be used to facilitate a process. So for example, we could have a flour mill, right? Because beside that stream, and the water wheel would use the process of the stream to mill the grain into flour. We could also have like a hydroelectric plant there by that stream, and it would use that process to create electrical power. So we can take that stream as it's flowing by and grab some content out of it. And that's kind of how we can look at some really advanced file processing today. Now, thinking about that file as a stream of data that keeps flowing, there are some things that we need to be aware of. When we're looking at files, first of all, the file name is comprised of the path. So in this example, we're saying that it's on the C drive, and it's in a folder named My Folder, in another folder named Data, and the actual file name is file1.txt. So the path part of that file name is the drive letter and all of the folders. And then the file name part is the actual file name and extension. So a text file we know could be opened by, Notepad or many other programs, but that file extension determines the file association. Now, when I am looking at a file name, I could specify an absolute path name to the file, and that would be this complete name, starting with the drive letter, going all the way to the file name. Another way that I could refer to it as it is relatively. So if I only use this file name, the screen part, that would be relative, and I would be saying or indicating to the operating system, whatever folder I am currently in or currently using, look for this file, file1.txt. Now, when we're programming, we always want to use a relative path. We might include a folder name. We might say images /image.jpg, but we always want it to be relative. Our path name should never begin with a slash or a drive letter in our code, because that's going to be specific to an individual machine. So if you were to turn in an assignment and you specified this full path name in your code, I wouldn't be able to access that file because I don't have a file named file1.txt on my C drive in a folder named My Folder in a folder named Data. But if you sent me a project folder that had this file in it and you only referred to it in a relative manner, then I'd be able to access it. So to be very careful to only use relative paths in any code. This snip here is a picture of a project folder from Visual Studio, right? So we have the bin, OBJ, and properties folders inside this project folder, and then we have several individual files. So they're all relative to that folder name. I can refer to any of those. A buffer, just as I reference here, something that you guys are pretty familiar with, but a buffer is just a temporary location for a data stream. So I might be reading data from some giant file or giant database, but I'm using some sort of buffer to hold that data as I process it. Excuse me, big drink. Now, looking at our C# Pro book, the black and gold one, file handling is in chapter 20, and it's the beginning of chapter 20. About halfway through or so, chapter 20 gets into some more advanced topics that have to do with C#2, but you can refer to that textbook if you like for information about file handling. You have a lot of the same type of information that we'll be looking at today in the PDF. This is the Doyle PDF that I've attached to our Canvas course. And in this PDF, we're looking at chapter 13. So anytime we're working with sequential files or binary files, we're going to be using classes from the system.io namespace. So we'll be using a using parameter for that namespace. Within the namespace, we have several classes available, several directory classes. In a directory, when we're using that keyword, a directory is exactly the same as a folder. Whenever, DOS was first created, they called the directories directories. And then they kept saying in documentation, a directory is just like a file folder you can think of, just like a folder. And people said, well, then why don't we just call it a folder? And so Microsoft did, but they never fully accepted it because they still refer to everything programmatically as directory. So a directory is a folder, no difference, just two names for the same thing. So we can use the directory class to get information about a folder, like does it exist? We can use the directory info class to get information about a folder, like does it exist? And we'll look at the difference as we're going through the examples. We have file and file info classes. We can look at streams. We can check for problems. And we have stream readers and text writers. So we have a lot of different classes available and at our disposal. So that's great because that means we have a lot of flexibility. We can handle things in a bunch of different ways. But that also means it can make it difficult to find help or examples that are doing things in the same way that you are. So be careful about that because they might be looking at some other class that's just a little bit different than the class that you've started out using. So that's okay. We just have to be aware that we're looking at that different. Whenever we're looking at the library for our file and directory IO information, IO, input, output, whenever we have a file or directory object, it inherits from the base system object. And by default, we have io.file and io.directory classes. We'll look at those. We have io.binary reader and binary writer classes, and those are very similar. Then underneath our object classes, we have some classes that are very similar, but define instances of files and folders. So just a small difference. So we'll look at that. Whenever we're working with a file, we could copy it, delete it, check to see if it exists. So lots of these different types of methods that are available to us when working with files. So we're going to write this program. This program is going to help us just to figure out if a file or folder exists using some of these directory structure commands. So let's try it. I have Visual Studio 2017 or 2019 is what this one is for the very first time. So I finally got some issues resolved with my Microsoft account. So yell at me if I'm doing something dumb here because I haven't used it before. So let's create a new project. And I would like for today to be a console app. And let's see, I'm probably going to have to install a few more different things. So I'm going to have to do a .NET Core console app. Haha, I can do a .NET framework. That's what I want. All right, so I'm going to do my .NET framework because I hadn't used the .NET Core before and I don't want to have to install a bunch of stuff. For this solution, I'd like the solution to hold a few different projects for us because we're going to be working with a couple of applications. So let's make it Chapter 13, File Handling. And I'm going to create that. Find my mouse. Found it. Zoom in here a little bit. All right, so we need system.io. And for this application, we're just going to do a few console commands. But first, put a comment up here. And the file that we're going to work with, just for the fun of it, is Bird of Paradise. So I'm going to drop it on our Discord channel here. You don't want to choose this one, but it's nice and pretty. Like a spring day, you know, sort of a Hawaii day, I guess. I didn't know that that was a bird of paradise, but now I do. And just save that file to like your pictures library or something, because we don't want to bring it into this project yet. I want to show you how things are going to react if we don't have it set up in our project. So in our main, we're just going to do a little bit of file handling here. Let's set up a string to hold our file name. And our file name is birdparadise.jpg. And of course, we're case sensitive on that file name. We have to match exactly. Now, we're going to start out using the file class. So notice using the file class, I can just specify the class name, and when I put the dot, it's giving me all the methods available to the file class. What does that tell us about the file class? It's static, right? There's only one. It's a static. It's all static. We don't have to create an instance of the file class. We can just say, hey, file class. Yes. Oh, that was in Discord. Let me see where it went. Okay. So, sorry about that. In our file class, we just can use the class directly. So we're going to say, if this file exists, what file? Well, the file specified by file name. If that exists, we're going to return a true. So if it does, let's write out some information about that file. I want to write out, first of all, the file name. So we'll use our interpolated strings to write out the file name. And then some information about the file. One thing that we can ask about the file is about its attributes, like if it's hidden or read only or any of those kinds of things. We want to get file class dot get attributes method using our file name. So super easy for us to use that file class. We just specify the keyword file and then the method. Let's do another right line this time. We're going to get the created date. So you see we've got the get created Get creation time. We'll get that one. For our file name. Whoops. One more. Let's get the last accessed. Let's get last access time. Perfect. So if we can find our file, we're going to get all sorts of information about it. What have I messed up there? What I'm missing my closing or something. Get last access time. Missing my file name parameter. So we'll print out all that information if we can get to the file. But if we can't, let's print out a message. So we'll add an else. So I want to interpolate that one also. And we're going to say file name not found using current directory. We'll go ahead and end things with a read key so we can sit there for a minute, or as long as we want. Let's see if that runs. Bird of paradise.jpg not found using current directory. Is that correct? It is, right, because I haven't done anything with that file, so I have it in my pictures folder out there, but I didn't tell that to this, right? As far as my project knows, this should exist within my project folder. So let's try that. I'm going to find my picture here. And can I just drag and drop into my project? There it is. I dropped it right on my project and it created it. And now it's in my project folder. Can you get yours in there? Now you could right click and add existing item and pull it in that way too. I just tried to drag and drop to see if that would work. So now I'm going to run because I've got my bird of paradise. And I still get the same message, not found. So I'm going to delete my JPEG file out of my project folder. That didn't work. And I want to delete it just because that's easier than us trying to move it around. So the problem is this source code folder is not the current folder when our project is running. When our project is running, it's our object code, our executable folder. That's our current folder. So we can get to it using Solution Explorer. If we change our view from solution view to folder view, right? Yeah, huh? Question? Do you have a question, Mohammed? He just got unmuted. Okay, no problem. Now I changed that view to folder view. And when I do that, now I see my project folder. And I see inside of my project folder, my bin folder, my debug folder. And as long as I'm debugging this project and don't release it, I'll be working with my debug folder. So that's where I need to copy my image file. Because that's actually my current project folder when I'm running. Okay, now I could do File Explorer and drill down in File Explorer and find the same place and put that Bird of Paradise file in this folder that way too. That's fine. But I need to switch my view back to run my application anymore. So I'm going to switch back to the solution. And now I should be able to run it. Now it does see, whoops, my Bird of Paradise file. Make this a little bigger. Doesn't have much. You can see that it's found the file. It tells us it had the archive attribute set, which means it hasn't been backed up. I believe that. It says that it was created today at about a minute ago and accessed about a minute ago. So that looks good. We're good? All right, so we can get to our files and find out about files. And we might need to, because we might need to create some sort of file or folder structure for our application to keep test data or things like that. So that works for us well. Let's add a couple comments. So this file name is relative, right? It's relative to our project folder. And then we're using the file class and it's static. We could call it directly file.exists, just like that method is in our code. Okay, everybody's working okay? Got it, got it.
Yep, it's working good.
Yay. Now in this example, we see the file class. The directory class is the same way, where we could say directory.exists because it's a static class also. We're going to look now at the info classes that are not static, that require us to create an instance to use them. And so I really want you to get that clear in your head, because it was always a real big source of confusion to me. And you know how when stuff was confusing to you, you always think that it'll be confusing to others. But I didn't understand the difference between the static classes, where I use the class name, and the instance type classes, where I had to create an instance of the class. And so with these file classes, it's very, very clear because they're very separate from each other, but yet they do the same kind of functions. So let's create that project. In our solution, let's add a new project. And this one is going to be a console app also. And let's make this one file info. Whoops, I told you I haven't used this one. I want this to be a console app, .NET framework. And I want to name this one file info. So again, we're going to use the file info class instead of just the file class. First, we're going to create a directory info instance. So we're going to use, whoops, we better fix our using clauses or we won't be using anything, huh? System.io. And now directory info should be recognized as a valid class. So we have to create an instance of our directory info class. We're going to call ours dir and say, yep, it's a new directory info instance. And the directory command that I would like to run for this directory info would be looking at the current directory, or dot. Let's go look at that. Right here in our file info project and solution explorer, right click and choose open folder in file explorer. So right now, this is my current directory, this file info directory. And if I click up here in the address bar, I'll see the full path name to that directory. It's on my C drive in my users folder, etc. If I select that directory name and type cmd, I'll open a command prompt in that directory. That will be my current directory. And we can tell that because that command prompt has that full directory name. Now, the directory info command is basically doing a dir command. So if I type dir, I see everything in this project folder directory. There's a few other directories, there's a few files. If I type dir space dot, I should see the same thing. Yeah, because dot means the current folder. So when we put that dot in our directory info parameter, we're just saying use the current folder, okay? So that's all that's going on there. It looks like a bunch of magic if you're not got your DOS commands. So we want to do a directory command on our current directory, and then we're going to use console write line to output some information. Let's see if I can do this with the interpolated string. We want it to say current directory, and then go to a new line. Then right after that, we want directory dot get current directory. Phew. So notice we're not using our dir instance, we're using the actual directory class to say, get the current directory name. So we will call that method. So that's going to be our first line of output. This is not dependent upon our directory info instance, is it? Question? Let's write out another line then. Now this line that we output is going to be like a heading. So it doesn't really have any parameters. We're just going to say we want the word file name, but we want it to be padded to the right by 52. If you guys remember some of this formatting. Then we want the word size, but we want it to be within a column that is 10 characters wide, plus the words creation time. So this is going to be like a heading. That's why it's specifying the sizes, because it wants to set up this heading line so that it'll match up with the information that's going to be displayed. We're going to use a for each command to display this information. And what we want to display is information about each of the files in our current directory. For each of those files, we're going to say this file is now a file info instance named FIL. And we're going to use our dir instance get files method to get all those files. Why do you not like our file info? We'll see. I'm having trouble before. For each of those files, then, we want to get the file's name. We're going to get its size. We're going to use a date time variable, creation time, to get the creation time. So notice we're getting some of the same data as we got for that individual file in our last program. We're just using this file object instead of the file class. Now, why it doesn't like my file info? Ah, look, it's because I named it the same thing. So I need to change my namespace. Namespace file info 102. There we go. Now it's finally happy. I was like, what is wrong with it? Okay, now to continue on with our file info, our size variable should be coming from file.length. Creation time from our file's creation time. And then we're going to do, finally, a write line. Now, our write line, first of all, is going to include our name, and we want to use the pad write for 45 on it. Then we're going to include our size, and it doesn't need any padding. And then our creation time. Put a closing curly brace. And finally closing double quote. Get everything closed there? It's really not that bad once we look at it. It's just way different from the textbook. So fine, we're saying start out with a directory or a folder. Tell me about it. Now, within that directory, write out every file that's in that folder. I'm going to go ahead and after our for each, put in a read key. So we can see what it's going to do. All right, let's try it. I didn't want to run that program, did I? I want to run our file info That looks better. So here's our folder. It is my project folder. My project folder's bin debug folder to be exact. And there's an executable file in there, a config file in this database for my publishing information. So those are the files that are within my project folder. So that looks good. Perfect. Any comment we need on that one? Let's try it. We're creating a directory info instance. Then we're going to process each file in the directory. Set up a file instance and use it. So this is super handy. I don't know, like one thing that's fun to write, you know, you never see a space display on Windows when you're looking at your hard drive, and sometimes you wonder what folder it is that's taking up all your space. So you can write your own application that navigates through all your folders and tries to zero in on where all your space is being used. I did it one time and was surprised to find out it was my users folder because I had installed the Android Development Studio, and it was eating up like all of my space. So I was glad that I had created an app to do that just for the fun of it, to see what it did. So that gives us two good projects where we're processing some files and folders, and we're getting to me to really see the usage difference of those static classes and the non-static classes. I know medicine, but sometimes you have to reinvent the wheel or else the wheel just is like already invented and you have nothing to do. Make yours better. No, I know there's some really good ones. So let's create a project that writes out a file. We want to be able to write out a file, just a text file. So let's create a little Windows form. I'm going to go ahead and use this same solution and add a project. And this time I want a Windows Forms project. And this one is going to be write saying. So we're going to be writing out a text file, a saying file. I'm going to rename our program.cs because we've got 3 of them now. Let's rename this and we'll call it writesaying.cs. Sorry about that, deafen you. And I want to go look at my form. So for this application, since it's forms-based, it's going to let me do it. I think it's being slow since I haven't used this yet. Now, writesaying is my program.cs file that just starts up the form. It's just not letting me see. Is it mad at me? I changed something. I think it opened in the other tab. Is it the second one? This one? No, I just don't have a designer. I think I'm gonna have to go back to 2017 because it's like it doesn't know. Well, we just won't let it kill us. I'm gonna open it in 2017 and see. See if it's nicer to me. Oh no. Yeah, it just doesn't like it. I'm going to create a new one. I obviously didn't have something properly loaded, so let me just delete that. And I'll create a new one. That looks better. Get it somehow. Okay, so finally, here I am. I've got my form. I'm going to change some things on the form. First of all, the text property. This is going to be store sayings app. And I want to change my back color. And my for color. And my font. I'm going to make it at least 12 so it's a little more visible for you. And then I'm going to make that a little smaller. Now for our application, we're going to have a label up here, a heading, and I'm going to make its text property say enter favorite saying. And I'll make the font a little bigger on that because it's kind of a heading. And we're going to have our user enter their sayings in a text box. Put it here. And we want it to be multi-line. So we want them to be able to enter a lot of different sayings. So I'm going to change our multi-line from false to true. And then I want a button. So when they click OK, we'll save their saying. I can make this a little smaller. Find a button. My button is going to say store saying. And I'm going to make it be named button store. I'm going to fix my back color bug. And then the last thing I need, I want a status message down on the bottom, like we did in our audio CD application. In our audio CD application, we made it a text box. Let's use a label for this one. Shouldn't be much different. But in our label, let's name it label message. I don't want it to start up saying label 2. So I'm going to change that text property to say welcome. Something like that. How's that? Look good? Everybody got it? Let's save it. Miss anything?
Good here.
Good, good. Okay. So our code, we're going to have some code associated with the form load, and we're going to have some associated with our button. So let's say, yeah, Dylan, it's a text box, and on the text box, find the multi-line property and change it to true, and then it'll let you make it into a box like that. Excuse me, so let's double click our form to make our form load event. A few weeks ago, our semester goes so fast, so it seems like it was just the other day. We worked a little bit on try-catch statements, kind of you guys did, had to do a little bit of self-study on that. And we're actually going to finally put a little bit of that to use, so hopefully it'll gather some more meaning. The first thing we need to create, though, is a class-level variable to hold our file information object. So our file information object is going to be part of that system.io class. So I'm going to make sure and leave my system.windows.forms using statement. I'm going to get rid of all the rest. All I need are those three. And then I want to create an instance variable to hold our file information, our stream writer. And our stream writer variable is going to be named FIL. You can tell this stream writer has to have an instance. It's an instance requiring type class. Now in our form load, we're going to set up our file. So we're going to start with a try. So we're going to try to do what's ever within our curly braces here of our try command. And what we're going to do is set up our instance, our stream writer. We're going to say, hey, our stream writer is a new stream writer using this file named saying.txt. So the parameter we're passing it is our file name. And our stream writer is going to try to open that file. That's going to happen for us. So if we try to do that and everything's fine, we're just going to go on and continue on with our code. But if there's a problem, we're going to try to catch that problem. So one of the problems that we might encounter is a directory not found exception. Like I can't find the folder that file is supposed to be in. If that were to happen, Windows would build this big exception object, contain all the information, you know, everything going on our computer at the same time, all of that kind of stuff, and it would pass that to us. We're going to refer to that object as exe in our code, and we're going to use that exception object to gather some information. So we're going to set up our label, our message label, to display the information. First of all, we want to say invalid directory. Then we want to add to our message whatever that exception object's message is. So our message is going to be invalid directory, and then we're adding on the exception information. So that's what will happen if a directory not found exception occurs. We'll catch it, so our application won't crash. We'll just display a nice message to our user. Now, another type of error that we could encounter is just an IO exception. This could happen because somebody pulls a flash drive out of the USB port right while we're in the middle of writing a file to it, or the network goes down right as we're in the middle of writing a file over the network. Something like that. Hard drive could crash. So these things are pretty unusual, but they can happen. If something like that happens, we're just going to go ahead and use the exception. Whoops, I didn't name that exception object. We want it to be named EXC, and then we use that exception object to just display its message data. So again, instead of that big crash message that shows our code and stuff, we'll just display a nice message with our label. System is unavailable, or whatever it is that we want to display. So with a try catch, we're just trying to run our statement, and if everything goes good, we won't catch anything. Right? It's kind of like going to Walmart, right? You're just trying to get your stuff, and if everything goes good, you won't catch anything. You'll get out of there with just your stuff. That's how a try catch is. We don't want to catch anything. We just want to try it, and we want to make it. Let's try and run our application here. Let's see, we want file info. Oh, no, right saying. All of mine ended up with the 102 on them. And in our right saying project, no bad things, no bad messages. So far, we just have our form load, so that looks good. All right, now let's make something happen if they click our button. So I'm going to double click our button. Now at this point, in our form load, we opened our file. So we're sitting there on that form with that file open. So when they click the button, then we're ready to put some stuff into our file, whatever it is that they typed. But we still want to use a try catch, because whenever we're using file IO, we are prone to errors. We're going outside of our program using the operating system a lot. We don't normally do that, right? Normally we try to keep everything contained within our program, but now we're using files that can be error prone. So we're going to try to write to it. Our object is named FIL, and we want to write a line. So just like we would write a line to the console, we want to write a line to our file. Now the line we want to write is in our text box 1. Oops, I'm going to go rename it. Bad. Go back to design. Click on our text box to rename it. Text box saying. And then go back to our code. Phew. Almost named that thing bad. Text box saying dot text. And that's what we want to write out to our file. Now, when we write that line to our file, we've gotten it. We've got it. That's great. Let's go ahead and clear out our text box saying. Of course, we could do the dot clear method. And then let's make sure that our focus is back on our saying text box. So we had all of that within a try because, again, they could have yanked that flash drive out or something between the time that we open this file and the time that we try to write to it. You never do that, right? Yank out that text file and then look at the screen and go, oh, wait, okay. Well, if you do, we're going to catch that error. Now we're going to catch any system.io.io exception in this example because we know things happen We want to call that exception EXC and update our label with the exception message. Something bad happened. We don't know what. So let's update. Yeah, that you can do that too. Let me show you. If you type the word try and then press tab twice, it puts in the curly braces and the catches for you and then gets you all confused by typing in this throw keyword that you don't need to have because you're catching an error, not throwing one. But anyways, try, tab, tab. We'll build that structure for you. Yes, there are other shortcuts like that. So like, can we do if, tab, tab? So it does things. Sometimes it's like, you know, you have to decide if it's better or worse. But there are lots of them. You can try it really almost with any keyword. And sometimes like if I'd already typed the condition and then I do tab, tab after that, sometimes it'll go ahead and build the rest of the structure. So do try it. Yeah, it is good. Especially in the try catch. People have a hard time. What's CW tab tab? Yes, control word, duh. Having a hard day. Yep, mind blown. Oh, there's so many. You have to look. And it's really bad, you guys, because you have to remember for those kinds of things, a lot of times in our beginning class, I won't use those because people, you know, we move very quickly, and so it can be easy for people to get off. And so anytime we use a shortcut or anything like that, it can make it harder for people to stay on track. So yeah, I'll share with each other stuff like that, because sometimes I forget to even that they're even there, because I'm so busy having to do things this just the old-fashioned way to make sure people can see it. So it's a hard one. Oh, so hard. All right, so we should be good. I want to put in comments. That's what I was going to do. So I'm going to stop doing that silly thing. It won't let me do comments. I'll put them here. Try to write a line to the file. And then right here we'll say catch any errors that might occur. Yeah, IntelliSense can be super annoying, and people can be off like on 7 other files. Where are you? All right, let's try it. We should be able to write some stuff into our file and click our button. So let's see, the early bird grid bird catches a worm. I'm going to store that. Our clear works good, right? It's got it cleared out. Folder. This is the one for me today. The hills and twice as dusty. Heard that one. There's a lot of Ozarkian ones you can't really say to students, I think. All right, so I'm writing these text files. Is anything happening? Let's check. I'm going to stop running. I want to go look at that folder view. Do I have a saying.txt file? Let's see. I don't want to be looking at my first project. I want to look at my write saying project, and it should be in my bin debug folder. And sure enough, there's my saying.txt file. So it has created it. I'm going to open this folder in File Explorer. Right click, open in File Explorer. And I'm going to go into my bin debug. And because I have my view set to details, and I have hidden and file name extensions checked, because I always want to be viewing directories that way as a developer, I can see my saying.txt file is empty. I put some stuff in it, but it didn't matter. So it got created, but it's just empty. Well, the reason is I haven't closed it. I didn't properly close it to tell the operating system I was done using it. So my changes were not kept. So how could we close it? We could, if we closed it here in our button event procedure, then that would mess up the fact that we open it in our form load. We really don't want to close it until we close the form, right? Yes. Yeah, so closing it, it's like lets the operating system finish up writing all of that information to the disk and making sure that it's actually saved. So we have to make sure, you know, the end of file markers are written to it and things like that, that the operating system takes care of. So for us, it would probably be best to close our file when somebody closes our form. So let's look at our form. And on our form properties, let's look at our events. Now we have a lot of form events. There was one, let's see, someone saw this morning, leave. Leave occurs when the control is no longer the active control of the form. That might work. I'm not sure. That's an event that I haven't been super familiar with. I know that the form closing or closing event will work. Do you see it? Oh, I'm looking at my button. Let me look at my form. Form closing. Now I find that event form closing. I'm just going to double click in this white area and Visual Studio will automatically create that event procedure header for me. Now in this form closing event, we're still going to put our close within a try catch. Because again, somebody might have yanked that flash drive out. I'm so glad they're flash drives because it's such a good example of what can happen. Now we're going to try to close it, but if we have any error, we're just going to update our message and say, file did not close properly. Now, are we ever going to see that message? We don't know. Unless we set up a test environment where we've yanked a flash drive out, probably we're not, because the form's going to go ahead and close. Right? So we didn't redisplay it or anything, so we won't even get into that mess, but we're handling it. Let's try running it now. Where am I? Here's my form saying project. Early bird gets the worm. Oh yeah, that's a good idea. A message box would be much better. We'll click our store saying button. I'm going to do another one. Older than the hills and price. Now, if I look at my file before I close the application, my saying.txt file is still empty. If I open it, nothing in it. Now I'm going to close my application here. Should run our form closing event. And now there is something in my file. I'm going to open it. And there are both of my sayings. Yeah, I think a message box would be so much smarter. How'd that work? Does it work? Is it working? You'll have data in your file.
Yep, it's working for me.
Data. We want all that data, so that is great. Oh, okay. Let me stop sharing so you can share. Show us what you got. So go. That's one way. What I was doing this time was looking at File Explorer. I think it's easier. Yeah, just, and then go into your bin folder and debug. And that is our first one. So go up to File. Where are your stuff? Right click on your Right Sayings project, the Right Saying 102. And let's open it in File Explorer and see where it is, because it looks like they're not in the same folder. So it ended up in your repo as its own thing. So that's why it's not showing up in that other folder, which is okay. Go into your bin debug on it, but it's just a little disconnected from your solution. Okay, so let's try and run it. And then close. So let me ask you a question. Let's run it again. If you use the big red X up in the corner to close, or you're closing your form, right? But if you stop running using the red button up there, have you taken control away from your application and just shut it down? Do you see the difference? So do it again, say hi. Store it. Now close the application. There you go. Now let's see if we have something. There we go. So see how just that little teeny difference in how you close it too. So I don't know why it's not in the same folder. It must be that Visual Studio 2019 weirdness. That looks good though. Let's try and read our file. Let's see if we can. Up in our form load, let's try a little bit of a different thing before we do that. In our form load, we say that we want to look at this saying.txt file. Oh, thank you guys, not sharing. How's that? Better. So in our form load, we say we're going to open saying.txt, and since it's a relative path, we're just using our project folder. But what if we made that into an absolute path? We could use the @ sign to say that this is an absolute string, and let's say it's in a folder named Bob on our C drive. So I don't have a folder named Bob on my C drive. So the system is not going to be able to create this saying.txt file. It would only create it if there were a folder named Bob, right? Because that's where I said I want it to be. We saw it will create it, but it's only going to create it if it can. So let's try running this way. Now we get the message out of our catch that says invalid directory, could not find a part of the path C:\Bob sayings.txt. So our try catch, we ran into this directory not found exception, and I'll put a space at the end of that. And we were able to give the user that information without crashing, so that it was much nicer for them than if we would have crashed everything. So I kind of want to read in our sayings file. Let's see if we could do that. So right now, we've got our Stream Writer project. I'm going to roll it back up so it's not quite so messy. So let's say we want to create an application called Read Saying. I'm going to go to my solution, right click, add. Don't be weird. Oh, I'm looking at that file view. So I'm going to change it back to my solution view. Roll all these up. And then I want to create one more. I'm going to add this new project. It's going to be a Windows Forms. And I want to call this one Read Saying 102. Let's fix our format. And we're just going to call this one Read Sayings App. And make your back color and stuff whatever you would like. I want to make it different so that I recognize this is the other form. And I want my font to just be a little bigger again. And this one, let's do about the same thing. We can do it pretty quick, huh? So we want a label. And this label will say saved sayings. And I'm going to make this big because it's going to be our heading. I'm going to put a text box under it. And make it multi-line. And I'll put a button. And I'll make this button be okay. And button okay. And then I didn't name my text box right. So I'm going to name it text box saying. And lastly, I need a label at the bottom for our status message. So I'll name it label message. And let's do this one just like almost exactly the same. I'm going to double click on the form and set up our instance variable. But this time it's going to be a stream reader instead of a stream writer. We'll still call it file, F-I-L. So in our form load, let's try to read it. We can use the file class to see if our file even exists. If our file exists, we call it saying.txt. Saying.txt. Just wanted to make sure that looks right. So that is file name. So we're going to say, oops, nope, no semicolon there. This is an if statement. If that file exists, we can do some things. Let's try them. So in our try, we're going to try to allocate our file. It almost seems like we should have a variable to be holding that data, doesn't it? Kind of silly for us to duplicate it there, but that's all right. So we're going to say, check to see if that file exists. If it does, try to open it. And if you're able to open it, go into a while loop. And we want to read in our input file. I need a variable to hold that data. So I'm going to create that variable up here at the beginning, sorry, of our form in file. So that's going to hold our input data. So while let's not make it in file, let's make it in value. It's going to be our input value. So while our input value is something that we can read, fil.readline, if we can read something, our input value is not going to be null. So as long as we can read something, we can process it. I'm missing a parenthesis here or something. I think that this green one should be here. There we go. So we're going to read our input file into a variable named inValue. As long as inValue is not null, we know we were able to read some data from our file. So we can add it to our text box. So let's add each line in our file to our text box. And then I'm going to add a carriage return in a new line to try and make that text box go down to a new line. See if that works. Now, we need a catch for our try. So we've got an error there. So let's put in our catch. First of all, if we get a system.io.io exception, we know that something went wrong. Let's refer to that exception object as exe, and let's use our label to output some information. So good. We got our try catch in. Now, what about our if statement? What if our file does not exist? An else clause. If we've got no file, let's set our message equal to file unavailable. And then the other thing that might happen is our try loading all of our data could work properly. So right here after our catch, we would be ready to update our message to say file loaded. Try it. I'm going to save this. We've got a lot here. We're starting out in our form load, declaring a string to hold our input value. We're checking to see if our file exists. If it does, we're going to try opening it and reading it. If we run into an error through any of that, our catch clause will catch that error and will output information in our label. If we don't run into any errors, we'll update our label to say the file was loaded. Looks good. Let's try it. File unavailable. That's right, because we don't have a saying.txt in this project folder. Let's put one there. I'm going to go find my saying.txt file that I've already saved and copy it. I'm going to go to my new project, my read saying, into my bin debug, and I'm going to paste it. Now I should have it in this project folder. Let's try it. Whoops, where'd it go? There it is. Clicked on stuff. Okay. The early bird gets the worm, older than the hills and twice as dusty. Okay, and my file loaded. Everything looks good. My OK button doesn't do anything. Where is it not updating your message? You want to look? Let's see your code.
Sure.
Is it letting you? Am I not sharing?
You are sharing, so I can't share at the moment.
No, let me unshare. Where is it?
Can you hear me all right?
I can.
Okay, just want to make sure.
There it is. It's got buttons all over the place, sorry. 3 monitors are good until you can't find the right button.
All right, so let me run it to see if it does. Okay, so it's grabbing this. I added I added the text file and it's reading it, but before
Uh-huh.
I added the text file, when it was not showing anything, instead of saying file unavailable like yours, it was just saying welcome still. Let me delete that real quick so I can show you. Read saying, I'll go ahead and delete this real quick. See,
Huh.
this is the code set up at the moment. Is there anything that I'm like missed? Because I think I was
That,
following along.
that looks right. Try changing it to not have the system.io.io exception to where it's just any exception, and let's see if it catches it then.
Oh, hold on.
Oh, the else statement is gone. He says
Oh,
that.
there's an else statement?
We put the else after the catch though, so you should still be seeing that
Well, just in case.
exception.
What is that?
No, you have it. You're right. It's okay. Because it would be after that. So you're okay. I'll put it up so you can see it.
Because I have that, like it's named properly because I went back and added it after. Like I went back and renamed it after. But it's got the correct name and it's hooked up.
Yeah, because it's like it's not changing your message at all. Because it still says
Yeah.
welcome like it would in your form. So
And
let's set a breakpoint. Go to your form load and let's set a breakpoint just, I think, within your catch. Let's see if we can see that it's running that line of code where you update that label. Yeah, over just a little bit further into the gray. There you go. And then we'll see if it ever even gets there. So it didn't. Put another one like within your while loop. Yeah, let's try to.
wait a second.
That's what Dylan was saying. You were missing the else. I see what he's saying. Yep, you do need that.
Yeah, we do, because I was about to
For
say
that
we
situation.
need the
Thank
else
you,
because
Dylan.
if the file's not there, it's not going to run any of
Not
this.
there at all. Okay, let me put this code back up.
So is it an if else, correct?
Yeah, so it's within the else clause that you would be getting that message.
Right, that's what I was saying. I just realized that now because if we don't have the file, it's not going to run any of these blocks of code. So, all right, I'll stop sharing for
Your
a minute
form
so I
is
can see
missing
what
a
that is.
close and minimize button. Oh, okay, I know what that is. Let's see if I can figure that one out. Okay, there's the code for our else clause that lets you get that file unavailable message. And then Dylan's form is missing the button. So if you look at your form in design mode, I'm looking at my form properties here, and where are we? There's a couple of different settings that can do that. The main one would be control box. I'm going to change that to false and run it and see how that makes it into something that you can't close. Is that what yours is doing? Or is it missing less than that? I'm going to change that back to true. Look like that one. Missing more, huh? Let's see yours so we can see what's going on. Oh, wow. Yeah, it's missing a lot. Let's look at your form properties. So it has to, no, go back to your properties one, yeah. It has to be something about the title. Scroll down, let's look at the very bottom. Gosh, I'm not even sure which setting it would be. I think it would be what's your MDI container? That should be false. Help button. The form border style, is that it? Yeah, change your form border style. So the normal would be sizable. Is that better? Showing everybody how it can get. One last thing that I didn't show you today that I showed the other classes. Whenever we're working with a form, you know how sometimes you want a certain button to execute when they press enter? You can do that with the accept button property. So if I change my button OK to be my accept button, then it will be my default button if I press enter. We hadn't really looked at that before. Oh, that's good. We're in good shape. Anybody got any more questions before we go? We used all our time today, so sorry about that. I know it's rough when you're sitting with all the other stuff going on around you. I see the sun out there. I'm going to get outside. So I hope you guys have a great day. I'll see you Wednesday, unless there's more questions. Thank you. See you then. Bye-bye.